Assalamualaikum and hi. Today we are going to represent about infrared radiation technology. There are 6 members in this group which will be represent about this topic. The members are Nordiana Safia binti Muhammad Sani, Nurul Husna binti Abdul Muttalib, Ahmad Irfan Hadi bin Ahmad Bushra, Muhammad Aidil bin Ramli, Nurul Nadia binti Khairuddin, and me, Siti Nur Elisa binti Muhammad Hilmi.
Hi, my name is Nur Nadia binti Muhammad Khairuddin and my student ID is 2022880992. This is our learning outcomes that we will explain in our presentation today. Introduction Infrared Radiation. Infrared radiation is a type of light that we can see with our eyes, but we can feel it as heat. It has longer wavelengths than visible light but shorter than microwaves. Common sources of infrared radiation include the suns, heaters, and remote controls. It used in many areas like night visions, TV remotes, and even in medical tools to see heat patterns in the body. Infrared radiation is all around us and plays a crucial role in our daily lives. Significance of infrared radiation. Application in our daily life and other disciplines. In everyday life, infrared is employed in remote controls for television and other gadgets, making it simple to control equipment remotely. Thermal imaging cameras in medicine utilize infrared to detect heat patterns in the body, which aids in the diagnosis of health disorder. Infrared is especially important for security and surveillance, as it allows night vision sensors to see in dark. In industrial, infrared radiation is utilized in heating operations such as infrared heaters and sauna to provide efficient and focused heat. In scientific study, infrared radiation spectroscopy is used to identify the chemical composition of materials. And last but not least, in astronomy, infrared telescope can detect celestial objects obscured by dust and gas cloud.
Hi, my name is Irfan Hadi, and now I'll be focusing on scientific instrumentation and application concept. Scientific instrumentation and application are fundamental aspects of experimental science and engineering. This concept encompasses the tools and techniques used to measure, control, and analyze physical, chemical, and biological phenomena. And there are several examples of application and usage of instrument. So the first one is galvanometer. It is used to reproduce the recorded sound. And bolometer used to measure heat radiation. And the last one is anemometer, measure force and velocity of wind. Next is the detailed exploration of infrared radiation. So what is infrared radiation? Infrared radiation is a type of electromagnetic radiation, EMR, with wavelength longer than visible light but shorter than microwave radiation. It is typically divided into 3 regions: near infrared, mid infrared, and far infrared. So the frequency range is roughly about 300 gigahertz to 430 terahertz. So what exactly is NIR, MIR, and FIR? Moving on to NIR, the near infrared, the wavelength closest to the red end of the visible light spectrum. The wavelength range from 700 nanometer to 1300 nanometer. Frequency range from 215 terahertz to 400 terahertz. Consists of the longest wavelength and shortest frequency, and it produces the least heat. Next is MIR, the intermediate infrared. The wavelength that range from 1300 nanometer to 3000 nanometer. The frequency range from 20 terahertz to 215 terahertz. For the last one is FIR, wavelength which are closest to microwave wavelength, extended from 3000 nanometer to 1 millimeter. Frequency range from 0.3 terahertz to 20 terahertz. Consists of the shortest wavelength and longest frequency, and it produces the most heat.
Hi, my name is Nurdiana Safia, and I will focus on examples real-world implementation for infrared radiation technology. The first one is thermal imaging. Thermal imaging cameras use infrared radiation to detect heat emitted by objects and create images based on their heat signatures. This technology is used in building inspections, firefighting, to locate hotspots, and medical diagnostics to detect abnormalities in body temperature. Common names for thermal imaging cameras include infrared cameras and thermal imagers. The camera's operation is quite straightforward and can be summed up in 3 easy steps. The initial step of imaging is gathering the infrared information from the environment. In order to accomplish this, the camera supplies the CPU with infrared radiation that are released by nearby objects. The raw data processing is done in the second stage. The device CPU usually converts the incoming data into an electronic image. The last stage involves laying out the processed data as an image onto the output screen. Thermal imaging is a common technique used to improve object visualization in low light conditions. Second example is night goggle equipment. Night vision goggles and cameras use infrared light to help increase visibility in low light conditions by enhancing available light, including infrared light, which is not visible to the human eye. Infrared radiation is typically used by night vision goggles for its operation. The basic working principle of the night vision goggles depends on a process known as image enhancement. By enhancing the light that is already there in the environment, image enhancement is a technique that may drastically enhance the view of sight. It can be easily observed that even during the night time or in dark places, some amount of light is always present. The small amount of light that is available might also include infrared light radiation, which are invisible to the human eye. This is allowed to improve the visibility of the objects present in the dark surroundings. Moreover, agriculture also is one of the examples real-world implementation of infrared radiation technology. In agriculture, farmers can track temperature variations in their crops through the use of infrared sensors. This helps them optimize irrigation and fertilization practices while minimizing waste. During fruit processing, infrared technology is used to evaluate sugar level and other quality indicators. According to this, fruits are guaranteed to be collected at the ideal time to be processed into goods like juices and wines, preserving a consistent quality and flavor.
I'm presenting about the benefits and challenge in infrared radiation. In medical and therapeutic uses, infrared imaging is used in medical diagnostics such as thermography to detect temperature variation in the body, which can indicate inflammation, infection, or other medical condition. In therapy, infrared is utilized for pain relief, improving circulation, and promoting healing in conditions like arthritis, muscle injuries, and skin wounds. In challenge, exposure to high level of infrared radiation can cause thermal injuries such as burn and heat stress, especially in industrial settings. And for the eye damage, infrared radiation can cause damage to the eyes if proper protection measures are not taken, leading to conditions like cataracts. In industrial application, non-destructive testing, infrared thermography is used to inspect material and components for flaws and defects without damaging them. This is particularly useful in aerospace, automotive, and construction industry. In heating, infrared heater provide efficient and target heating for industrial process, drying and curing application. As for the challenge, energy consumption, infrared heating system can be energy intensive and inefficient. Use can lead higher energy consumption and associated environmental impact. Cost and maintenance of developing and deployment and regular maintenance of infrared technology can be expensive, adding to operational costs. As for the environmental monitoring, the benefits of remote sensing, infrared sensors are used in satellite imaging to monitor the environmental change such as deforestation, urbanization, and climate change. They can detect heat emission from wildfire and volcanic activity. And for the weather forecasting, infrared data helps in analyzing atmosphere conditions, improving weather prediction accuracy. For the challenge is wildlife disruption. The use of infrared technology in the environment can potentially disturb wildlife, particularly nocturnal animals that rely on natural light cycles.
Now let's look at the future development and innovation of IR. The first one is improve IR detectors and sensors. It will become more sensitive, faster, and lower cost infrared detectors and sensors. Integrated infrared imaging system (IFC) will become more prevalent, enabling compact and low-power IR imaging and sensing solutions. The second one is expanded IR spectral coverage. It will push the boundaries of IR spectral coverage, expanding the wavelength range accessible for imaging, sensing, and spectroscopy applications. This includes extending the long wavelength infrared and terahertz region of electromagnetic spectrum. The third one is infrared, photonic, and optical components. The advances in IR photonic integrated circuits, FITE, and optical fibers will enable more compact and efficient IR light generation, transmission, and processing. Mobile IR optical materials, metal surface, and metamaterial will lead to innovative IR devices and components for sensing, imaging, and space communication.
As a conclusion, thermography has been proved as a powerful tool across in various fields due to its ability to detect and visualize thermal patterns and temperature variations. With its non-contact nature makes it particularly valuable in application where direct is impractical or unsafe. Besides, thermography offers a versatile and non-invasive way to interpret the thermal information with widespread applications across the industries, contributing to the safety, efficiency, and a better way to understanding about thermal phenomena. That's all from us. Thank you.